This video series is brought to you by Laoghaire-Rathdown Libraries, in association with Mark the Science Guy.
Racket was DJ Snazzy Sneeze Jeff featuring Whip Doodly Whoop.
Well, it sounds like somebody drilling through a wall.
I've been up all night reading this book and listening to BBC Sound Effects Volume 4, and I just really wanted to make a cool new beat with my new equipment.
I thought the DJs just pretended to press buttons and tried to look cool.
No, Ali. That's just the majority of DJs.
Well, Mark, an understanding of the basic principles is essential to anyone wishing to make some successful recordings. It says so in the book.
Oh.
So I think we should probably go back to basics, and first of all, let's investigate what sounds are.
Okay, let's go.
Now?
Huh?
It's 4 o'clock in the morning.
Yeah, but it's disco o'clock somewhere. A sound engineer makes things sound good. They operate and set up recording equipment and are responsible for the sound quality and technical side of a recording or performance.
Yeah, and they design and manage sound outputs, organise the sound equipment like the speakers, microphones, amps, recording decks and sound effects, and they edit, mix and master the tracks so that they make the best quality of sound for a variety of different purposes.
They make recordings high quality and nice to listen to.
Yeah, and anyone who's ever been to a concert or a theatre and was impressed by the quality of the sound they heard can thank the talented sound engineer controlling the sound.
And sound engineering involves lots of other disciplines too, like electrical engineering, mechanical and design engineering, as well as acoustics and music.
Busy people.
Busy people.
Okay, so let's investigate the nature of sounds.
Sound is a vibration, and sound is created when something vibrates, sending waves of energy to our ears.
Vibrations need to travel through something, and they can travel through the air or any sort of solid, liquid or gas.
And when those vibrations make it to our ears, we perceive them as sounds, and the stronger the vibration, the louder the sound.
And vibrations can be made in lots of different ways. Pretty much everything that we do produces some sort of sound.
Yeah, you can make your own vibrations by putting your hands on your throat and humming. Feel the vibrations?
Yeah. So when we speak, our vocal cords vibrate, and that's what allows us to make sound.
Ah. You can make vibrations in other ways too.
Nice. And here's a cool thing that you could do. Grab yourself a balloon and something small like one of these hex nuts. Pop your hex nut inside your balloon and then carefully blow up your balloon. Careful not to inhale your hex nut.
Tricky balloons.
Tricky balloons, yeah. So tie off a knot at the top of your balloon. Like that, and then just...
Like what?
Like that. And then just give it a spin.
Yeah. Ooh, what a noise. The screaming balloon. Sounds like strange race car.
They do sound like race car noises.
Slowing down.
Ah.
You're hearing those noises because the hex nut is vibrating off the inside of the balloons. And vibration is noise.
Pretty cool.
Yeah. Sound travels as a wave, and like all waves, it has a wavelength, frequency, and speed.
And sound waves in air travel at 340 meters per second. That is 1 kilometer in under 3 seconds.
That's fast, but nowhere near as fast as the speed of light. That's why if you're at a fireworks display, you will see the flash before you hear the bang.
And same for a lightning storm, you will always
Hopefully.
see the flash of lightning before you hear the sound of thunder.
Yeah, very cool.
Yeah.
Love a good lightning
Me
storm.
too, big fan.
Now, wavelength is the distance between each peak of the wave.
Yeah, and frequency is the amount of waves passing a certain point every second.
Let's make some musical instruments and investigate the relationship between wavelength and frequency.
Good idea. So for this first instrument, all you're going to need is a straw
Yes.
and some scissors.
Nice.
Easy peasy.
Okay. First, let's cut off the elbow bit.
Yeah, don't need the bendy bit.
No. Okay, and you don't have to be
Bye.
too particular in how much you cut off. Okay.
Get out of here.
Okay, so pick one end, and you're going to flatten it down about 2 centimeters or an inch inwards. So
Okay.
flatten it down real good. You can use your fingers or the back of the scissors.
Oh, good idea.
Then, staying on the end you've flattened down, get your scissors and you're going to cut a triangle shape into the top. So you end up with something that looks a little like this.
Nice.
Now comes the practice, and it does take practice like all musical instruments. You are going to make something vibrate. The little top, there like that.
Oh, those little triangles.
Yes, exactly. That's going to act like the reed in a woodwind instrument.
Nice.
So you're going to place your lips just past the little triangle bit. Now don't press down too much because you need the air to flow through, because that's what you want to get vibrating, and you want to create vibrations so you can hear sounds.
Okay.
So place your lips nice and gently and then blow. Nice.
The length of the straw and the amount of air vibrating inside it determines what sound we hear.
If we change the length of the straw, we change the wavelength. It gets smaller. There's less air inside, so it's easier to get that air moving, so the frequency of the sound wave increases. And we perceive that frequency as pitch.
Lots of fast vibrations have high frequencies, so high pitch.
Longer straws, more air, less vibrations, lower frequency, lower pitch. So you can make lots of different lengths and investigate how changing the wavelength changes the frequency.
We can also make a kazoo.
Ooh, let's.
So what you'll need for that is some lollipop sticks, a thick elastic band, 2 smaller elastic bands, and a straw. We're going to use a paper straw this time.
Yes, okay.
The first thing you're going to do is take your thick elastic band and spread it over your lollipop stick like that lengthwise. And then you're going to cut 2 short pieces of straw, so about 3 centimeters long.
That should work.
Doesn't really matter too much about the length of it. So just 2 small pieces of straw. Place 1 piece of straw underneath that elastic band that you just put on your lollipop stick. And the other piece is going to go on top of that elastic band. And you're going to make a kazoo sandwich.
Ooh, a kazoo sandwich.
Yeah. So pop your second lollipop stick on top and secure it in place with those smaller elastic bands. You might have to wrap it around a few times. And there you have your kazoo.
Okay. How's your kazoo skills?
Pretty weak.
Oh, let's find out.
Let's find out.
Okay.
Ooh. As you blow into the kazoo, the elastic band inside vibrates, which creates sound.
Sliding the straw up and down the kazoo changes the amount of the elastic band vibrating, so you can change the pitch.
Nice! You can make lots of different things vibrate.
Yes,
so,
you
for example, we have got some glasses here with different amounts of water inside them.
Okay.
And let's see what happens.
Let's make those glasses vibrate. Okay. As you rub your fingers on the rim, the glass vibrates, and you can change the pitch by adding water.
Very spooky.
Very spooky. Pretty cool.
Very cool. I really like that
Very
one.
nice movie soundtrack
It
music,
is.
isn't it? Oh. Oh, okay.
Very
all
nice.
right.
You can also make some other things vibrate. So here we've got some glass bottles, again with different amounts of water inside them.
Okay.
And let's see what happens when we blow over the top.
Okay. When you blow into the bottle, the air vibrates. An empty bottle is full of air. Because there's lots of air to try and get vibrating, it vibrates slower, not as fast, and you get lower frequency. Nice!
Nice,
Cool.
yeah. Adding water to the bottle decreases the amount of air inside, so it's easier to get it to vibrate faster, causing a higher pitch.
Ah,
Nice.
cool. Now, these are awesome, and there are lots of things that you can vibrate to make sounds. We also have these long tubes that when you
yes.
bang them, they make
They
sound.
make sound.
And we have got lots of them.
We got a few of them, all right.
Yes. So they are different lengths, so they change the different amount of air that's vibrating. We have a whole musical scale.
Lots of them.
Yeah, so Ali, let's get all our musical instruments together and let's do a live performance.
No pressure. Nice.
Okay, good start.
Okay. Loosen your belt buckle. Okay.
Sing it with us! What about that?
That was good fun. That was very good
Oh, that was
fun.
pretty cool. That was cool.
So sound engineers can also work in TV and film. So they use different instruments, technology, and computer software to create sounds.
Yeah, think about how boring TV shows would be without music. There'd be no good vibrations.
Let's make our own movie where we create all of the sounds.
Awesome. Hello? Ali, what's up? Where are you? Okay, calm down, calm down. Okay, great, okay. I'll see you in a minute. Great, okay, bye. Ali, hello! Out of that cold!
It is freezing outside.
You look cold.
I feel cold. Why are you wearing a t-shirt?
I have inside.
It's freezing.
Yes.
answer. Mark? What? Mark's scream is indicating that he's in trouble!
Ali, I got you some tea. Ali? Where did Ali go to? Oh well. More coffee. Seven Down, a washed up English comedian. Oh! Ali! You!
What happened? Where did you go?
I went to get some tea and then coffee. And...
Right, you disappeared, all the lights went off, and I kept hearing all these really, really weird noises. I didn't know what was happening.
Ali, you have an overactive imagination. Have some tea / coffee.
Spooky.
Good movie.
Good movie. Spooky, but
movie.
good.
Yeah. To record our sounds, we used a microphone, and a microphone converts sound into an electrical signal, and they're used in lots of things like telephones and computers.
We also use speakers, which convert electrical signals into sound waves, like in our TVs, radios, computers, electronic instruments, and microphones.
Sound engineers are very talented at producing lovely sounds we all want to hear.
But they can also work closely with acoustic engineers to make sure we don't hear the sounds that we don't want to hear.
This next bit might be useful for you too, Ali, if you're feeling a little sleepy.
Always.
Some materials allow sound to pass through them very easily, especially hard, rigid ones like metals.
Yeah, whereas other materials, especially soft ones like cotton wool, absorb sound.
Loudness of sound is measured in decibels, and ears are delicate and need to be looked after, because they can be damaged in lots of ways, especially by listening to music for a long time.
Yeah, most pop stars wear earplugs on stage to try and protect their hearing.
Foam rubber blocks are often used for soundproofing in rooms like recording studios, because they contain many empty spaces in them, so sound doesn't pass through them so easily.
And this is important to make sure that outside sounds can't get in, but also to make sure the loud sounds can't get out, which might upset the neighbours.
Household items like popcorn and egg cartons, they work really well for soundproofing too.
Okay, why don't we try and make our own soundproofing earmuffs? What we just used was some plastic cups. We filled them with different materials we could find around the place. So we filled some with some cotton wool, some with some newspaper, and some with some bubble wrap.
Okay, so you can test them out, different materials, and see which ones are the best insulators of sound.
They work And they reminded me of a really cool piece of engineering invented by electrical and sound engineer Dr. Amar Bose. The headphones that listen.
Oh, you want to pop them down for a second? In 1978, Bose was on a flight from Zurich to Boston, United States. He was excited to try some new Sony Walkman headphones on the long flight. What began as a pleasure soon turned to disappointment. The cabin noise in the aircraft was so loud it made it difficult to hear the music clearly over the new headsets. There had to be a better way, Bose thought to himself. It was the 70s, buckaroo.
Bose took off the headphones and got out a notepad. He began to create a design that would eventually become the first noise-cancelling headphones. The headphones that listen.
Bose designed a system that would use a microphone inside the headphones to pick up all the noise occurring in the atmosphere around the user.
That noise would then be sent to electronics that generated an equal and opposite signal within fractions of a millisecond that cancelled out the sound before it reached the eardrum of the listener.
The noise-cancelling headphones were born, and it took 15 years of engineering to make his idea a reality. Things take time.
What?
I said things take time! His designs became popular with airline pilots, the military, football managers and coaches, and now they're widely available and used by all sorts of people across the world. Needless to say, he had the last laugh. And as a professor at MIT, he would tell his engineering students the most important attribute an engineer can have is imagination.
Mark, I can't get over how well these things work. Thanks, engineering!
You're shouting!
What?
I think I need a pair of Ali cancelling headphones.
This video series is brought to you by Laoghaire-Rathdown Libraries in association with Mark the Science Guy.